Hey everyone, and welcome to this explainer. Today, we're unearthing a story that absolutely revolutionized how we understand the natural world. Look, if you think biological classification is just some dry, boring science where you memorize Latin names, you are in for a wild ride. We're going to explore a truly thrilling historical adventure filled with perilous wilderness treks, fierce scientific rivalries, and tragic global expeditions. We're looking at the life and a lasting legacy of Carl Linnaeus, the undeniable father of modern taxonomy. Okay, let's dive right into this. To really appreciate what Linnaeus accomplished, you kind of have to understand that before him, biology was an absolute mess. Seriously, imagine trying to communicate with scientists around the world using these paragraph-long strings of text, like Rosa sylvestris alba cum rubor, folio glabro, just to describe a single, everyday pinkish-white woodland rose. It was a complete nightmare. Linnaeus transformed all that chaos into an incredibly simple, elegant, two-word solution, Rosa canina. And the sheer scale of this chaos during the Age of Exploration was just staggering. Explorers were constantly returning to Europe with this absolute flood of new, exotic plants and animals. Older classification systems, like the one designed by the French botanist Joseph Pitton de Tournefort, were basically unworkable. I mean, he tried to squeeze roughly 10,000 known species of plants into just 688 arbitrary genera that botanists basically had to memorize by brute force. It was literally like trying to organize the entire internet into a few hundred desktop folders. Biology desperately needed a better filing system. So how did Linnaeus solve this? Well, he championed something called binomial nomenclature. Think of it as the ultimate biological life hack. It's a standardized method where every single species gets a simple two-part Latin name, a capitalized genus name followed by a specific epithet. Instead of trying to describe the entire plant right there in the name simply acts as a unique identifier. This brilliantly simple two-part system finally brought some desperately needed intellectual order to biology. Naturalists could finally remember names, and far more importantly, they could actually agree on them. But here's the thing. Linnaeus didn't just invent a neat naming convention. He built a massive, practical filing system for all life on Earth. And the best part? Anyone could use it. He organized plants based on their reproductive organs. Step 1 was determining the class, just by counting the male stamens. Step 2 was finding the order based on the female pistils. From there, plants were grouped into a genus and finally the individual species. It was this highly rigorous hierarchy where small groups were neatly nested within successively larger groups. He introduced this revolutionary and, frankly, somewhat controversial at the time, sexual classification system to the world in a seminal work called Systema Naturae. This was published in 1735 while he was actually studying in the Netherlands. This wasn't just a book, though. It was a total watershed moment that literally standardized the language of the natural sciences. It meant that a botanist in Sweden and a botanist in England could finally communicate effectively about the exact same organism without any of the old confusion. Now, Linnaeus wasn't just some armchair theorist. To prove his system actually worked, he put it to the ultimate test, out in the field. And this brilliantly illustrates his sheer dedication. In May 1732, the young Linnaeus embarked on this epic 2,000-kilometer trek through the harsh and unforgiving wilderness of Lapland, up in northern Scandinavia. Over the course of 6 grueling months, he traveled on foot and by horse, making deep inland incursions, enduring incredibly difficult terrain, and documenting the flora, the fauna, and the native Sami people. Seriously, imagine having a massive scientific epiphany while just staring at roadkill. Because that is exactly what happened. While examining the lower jawbone of a horse he found on the side of the road, Linnaeus realized his system could apply to animals too. He later wrote, "If I only knew how many teeth and of what kind every animal had, I should perhaps be able to work out a perfectly natural system for the arrangement of all quadrupeds." That exact random moment sparked his incredible approach to classifying mammals. That Lapland expedition was a massive scientific success. Even though the Arctic region isn't exactly bursting with biodiversity, he still managed to discover and describe about 100 previously unidentified plants. He used his brand new classification rules to document them, and these discoveries form the foundation of his milestone book, Flora Laponica. This text actually became the very first example of a modern botanical flora. So later on, once Linnaeus became a professor and the rector at Uppsala University, he obviously couldn't travel the entire globe himself. His solution? He sent his students. We're now shifting from the safe, quiet haven of Linnaeus's academic garden to the extremely high stakes and deadly reality of 18th century global scientific exploration. He hand-selected his most promising, most committed students to travel the world and catalog its biodiversity using his system. He called these 17 incredibly brave adventurers his apostles. But, cataloging the world back in the 1700s was definitely not a safe academic exercise. The staggering human cost of early taxonomy is actually incredibly grim. Out of the 17 apostles that Linnaeus sent across the globe to gather specimens, 7 of them never returned home. They literally paid for this biological knowledge with their lives. I mean, the fates of these explorers read like tragic adventure novels. Christopher Turnstrom traveled toward China but died of tropical fever off the coast of Vietnam. Per Forskall made incredible discoveries in the Red Sea and actually found a plant Linnaeus desperately wanted, but then he died of malaria in Yemen before he could even deliver it. Johann Peter Falk explored the Russian steppes but suffered from severe depression and an opium addiction, tragically committing suicide in Kazan. Meanwhile, Per Osbeck is one of the lucky ones. He sailed to China searching for the tea plant and successfully returned in 1752 with a massive, rich collection. And as you can imagine, this human cost created immense fallout back home. When that first apostle, Christopher Ternstrom, died of tropical fever in 1746, he left behind a wife and children in Sweden. His furious widow directly blamed Linnaeus for making her children fatherless. The controversy and the danger of these expeditions were so intensely real that from that moment on, Linnaeus made a strict, uncompromising rule. He would only send unmarried men to be his apostles. So despite the massive global reach and the deeply tragic losses of his apostles, Linnaeus's physical roots remained firmly planted right in Uppsala, Sweden. And you can actually step directly into this history today. These 4 lush, enduring locations, the Linnaeus Garden, the Botanical Garden, his summer residence at Hammarby, and his countryside retreat at Savia, are these perfectly preserved spaces where Linnaeus taught, wrote, and cultivated those hard-won global specimens. The Linnaeus Garden, for example, is just incredible. It's actually Sweden's oldest botanical garden. Now, though it was originally founded by Olaf Rudback, it was entirely taken over and redesigned by Linnaeus. Today, following a really meticulous restoration, the garden exclusively grows the exact plant species that Linnaeus himself cultivated. And get this, they are physically organized in the flower beds right now according to his original sexual classification system. It is quite literally a living, breathing museum of his mind. Okay, so here's the absolute crucial point. Why did Linnaeus' system survive when so many others completely failed? During his lifetime, he faced some fierce competition, most notably from the French naturalist Buffon. Buffon argued for a complex morphological system that considered physiology, anatomy, and ecology all at once to determine how organisms were related. But it was just overwhelmingly complex. Linnaeus's nested hierarchy won the scientific war because of its scalability. When a new organism was discovered by an apostle, you didn't have to rebuild the entire system from scratch. You just nested it perfectly into the existing hierarchy of class, order, and genus. By the time the 10th edition of Systema Naturae came out in 1758, his method had pretty much achieved total dominance. He became the very first person to employ binomial nomenclature consistently without a single exception for all known plants and animals. In fact, this 1758 edition is still recognized today by scientists as the definitive starting point for zoological nomenclature, absolutely cementing Linnaeus as the undeniable father of modern taxonomy. All right, we've covered a lot of history here, from completely unpronounceable plant names to these deadly global expeditions. But I want you to pause for a second and just ask yourself, how does an 18th century plant classification system designed by a Swedish doctor obsessed with counting flower petals actually impact our understanding of biology today? Well, it leaves us with this really fascinating paradox. See, Linnaeus built his system to tightly organize what he believed were the fixed, unchanging creations of a divine architect. But ironically, in doing so, he accidentally drew the exact map Charles Darwin would use a century later to prove that life is constantly changing. Darwin utilized this exact hierarchical grouping to support his theory of evolution by common descent, realizing that these neatly nested groups actually represented distant and recent shared ancestors. So the next time you see a simple 2-part Latin name, ask yourself, are we just looking at a label, or are we actually looking at a family tree? Thanks so much for joining me for this explainer.